Okay, good morning, good afternoon. So we continue the lecture of yesterday about agile programming and agile development of software. So just a quick summary of what we said yesterday. So the main problem of classic software development is the fear of change and the cost of change. And the problem is that the old way of developing software was a waterfall model that goes from requirements down to the final product, always going ahead and never looking back. And this is not very good because the basic assumption of this model is that you can know everything since the beginning and then proceed always ahead in a very structured way. Unfortunately, this is not the case because in most cases, software is subject to changes and is subject to changes in all phases of development. So if you have one single development cycle with phases that go from requirement to design to coding to testing to production, and you never look back, then you run into trouble because you may run into a modification that you have to do at the very end or the introduction of a new feature, and this means that the cost of this change later in the development is very high. So the dream would be to have zero or very small cost of change all over the development cycle. Of course, maybe this is too much, so we need something in the middle. So something like keep the cost of change low all over the development cycle, maybe a little bit more at the end, but constantly low. Now, how to do that is not very easy. One part of the picture is to completely change the development process. And so instead of having one single big development, you are going into small iterations, okay? And every time in a small iteration, you develop one single aspect, very small, of the system. And then you immediately interact with the market, with the user, to understand if everything is okay. And if there is something to change, and for sure there is something to change, you have to be ready to easily change your software. Okay? So, agile programming, it's about being flexible during the development cycle. Okay? So one aspect of being flexible is to be able to refactor your code often. What does it mean to refactor? So before going and looking at a real development process, and this will be done probably later today or tomorrow, we need to understand how it is possible to change existing code. So the idea is that you have something that is already working, and you need to introduce some change. For doing this, you need to make sure you are not going to introduce bugs in existing code, and you need to transform existing software so that you can introduce new features, or you can change the behavior of one part of the code. Okay. Now, taking an existing software and changing it is called refactoring. Okay. So it's a sort of taking something existing and trying to modify something. Okay, so it's so the idea behind refactoring is that if we could continuously maintain the code and keep it clean and as simple as possible, it should not be too difficult to change it, right? But of course, for doing that, it requires a method, because Code cleaning should become routine and be integrated into the process. And what does it mean, code cleaning? It means that when you develop one feature and you test and you make sure that everything works okay, you spend some time in making it more beautiful. Now, what does it mean beautiful? We are going to see it in a little bit, but of course it's your experience that tells you that one structure is better than another. So it's mostly experience. Of course, it's also studying the patterns and studying the techniques, what we have done all over during the course. But it's also experience, of course. So you develop your code, you implement your functionality, you test it. If everything is okay, you spend some time for improving the quality of the software by making it more beautiful and more clean. For example, smaller functions, you try to introduce something more clean in a function call so that it's easier to be used later on and things like that. Now, this code cleaning is not done very often. Actually, it's not done at all usually, because once you implement something and it works, the first thing you want to do is to go to the second feature you have to implement. And also your management is not happy if you spend time in cleaning code, because it looks like a waste of time. So, is it worth it to clean the code? Well, it depends on how many changes you anticipate in your process. If in the future you anticipate that you are going through many changes in your code, then it means you will need to go back and change this code. So it's better to keep it clean for the future. If instead, of course, it's some code that is quick and dirty and you wrote that just for making an experiment for your next paper, then maybe it's not worth to spend too much time in cleaning the code, of course. So it depends on the process, of course. So let's tell a little bit the story. And this is a story that is told, if I remember well, by Martin Fowler, one of the father of this agile programming movement. So once upon a time, a consultant made a visit to a development project. And during the analysis, he discovered that the hierarchy of classes was messy. It could be improved a lot. Okay, so the company was pressed. They did not have enough time. The code did not work very well, so they hired a consultant. This happens very often in software development. And this consultant came from outside and started to do a code review. It means he looks into the source code. And he discovered that the hierarchy of classes was a mess. He could improve it a lot. So he recommended the project management to spend some time cleaning up the code. Okay, he said, let's take 2 weeks where the programmers stop adding new features and just think about how to improve the internal structure of the code. And of course, the management was not happy. He said, oh, why we had to waste 2 weeks of time implementing something, making something that we already implemented more beautiful. First of all, since the code works, why we should modify it? It works. We cannot progress, but the code we have, it works. Also, we are behind. Of course, software development is always behind. There is still a lot to do. We are on the time and cost budget, so we cannot spend time and money just making the code more beautiful. What's that? So the consultant also talked to the programmers, not only to the management, but to the programmers of the problems. And so they started spending actually a couple of days cleaning the code. And the amount of code was reduced because a better structure means also smaller amount of code. And it was clearer and cleaner. And of course, the managers were not happy because after 2 days, not one single additional feature had to be implemented. And the usual thing is, who cares about nice code? The client doesn't look at the code, so who cares? The client doesn't care. And since the client doesn't care, we do not care. So after a while, the manager fired the consultant. Oh, this consultant is a waste of time. So the consultant was Martin Fowler, who is author of this book. It's called Refactoring. And 6 months later, the project was cancelled because it was too late, and they were not able to finish it on time. And after that, they hired another consultant, and actually was Kent Beck, author of Extreme Programming, and starting rewriting the code almost from scratch. So they had to completely throw away what was done until then. The reason of this failure was that the code was too heavy and too complex to debug and maintain. And this was mostly because of the very complex structure of the class hierarchy. Okay? So the code was too heavy, was complex, a lot of indirection, a lot of function calls back and forth between files. So it was complex to follow the thread of execution of the program. So it was complex to debug, it was complex to maintain, and of course it was very difficult to add new features. And this was one of the reasons why they could not progress, and 6 months later the project was cancelled. So in that specific case, probably spending some time cleaning the code and improving the quality of the code would have helped maybe doing the project on time. So what is refactoring? Refactoring is the process of changing a software system in such a way that it does not modify the external behavior, but improves its internal structure. So it is almost all about beautiful structure, let's say. Okay. So the idea is that it should be possible to improve the design, not just the implementation, but the design of existing software after the code has been written. Okay? However, to do this is not very easy because you have to be very careful and you have to be very rigorous. First of all, you must have a set of tests that prove that your software is working and does what everybody expects it to do. So you need to have a set of tests. And these tests should be unit tests and also maybe integration tests. Then you start changing everything in little incremental steps. So you are changing the internal structure and the internal implementation. And at every step, you need to run all tests to see if the code is still doing what we expect it to do. In this way, you make sure that by changing the internal structure, the probability of introducing new bugs is smaller because of the test. Of course, it's not null, because the test coverage is not 100%. So it all depends on how good are these tests. If the tests are very good, they have a good coverage, and so the probability of introducing new bugs by changing the internal structure is very, very low. But anyway, the idea is to do it step by step, little by little, and improving the design every time you do this cycle. So you have your program. The program must be working already, and you have to have all the tests in place. Then you need to change the internal structure. So you start it by dividing the big change into smaller incremental steps. And you implement one step, you run all the tests, and if everything goes okay, you implement the second step and you run all the tests. And if something fails, since the change is small, you can revert it back and you can understand what's going on. So step by step, little by little, you are going to improve the design. Why you need to do this? Is beauty important? In general, beauty is not important per se. It's not important by itself. Because the things that really matter at the end are functionality and performance. That's it. So beauty is not important in absolute. But the fact is that beauty in software code is not independent from other nice properties. Because beautiful is often simple. Simple code that achieves a nice algorithm is often also very beautiful. Independence and isolation are beautiful. So if you have a large program made by small independent pieces that interact in very simple way, everything is very beautiful. The structure is beautiful. Flexibility is beautiful. So the ability to change easily some part is also beautiful. So beauty, it's related to nice property of the code. It's not just beauty in the sense that it's nice to look. Beauty in code is about the nice internal structure of the code. And so this is related to functionality, and it's related to performance. So nice code is also code that has a lot of useful properties that will make our life easier later on. In classical software development, so the waterfall model, you do a very careful upfront design at the beginning. Then, after design, you do coding. Now, the emphasis is on making the design, the best one, the one that is correct and will solve all present and future problems of your software. Now, since it is trying to solve all future problems, extension, desires, it's often overly complex at the very beginning. It ends up that it will contain many features that will never be implemented because they are not needed. And in fact, this is one of the defects of programmers in general, and young programmers in particular. So when they start coding, they have the desire to apply all they know, and so they start by doing the design of the program overly complex. Okay, so they studied, I don't know, template metaprogramming, so template metaprogramming everywhere. Or they studied how to do functional programming, so functional programming everywhere. Even when this is not appropriate or it is not needed, and especially young programmers are like that because they don't have enough experience to understand the exact measure of the things since the beginning. Okay, so this happens a lot in design in the waterfall model because at the very beginning the designers make a large effort in trying to understand all future things that can happen, all future extensions, all future problems, all future desire. And so they make a very complex initial structure because they need to anticipate all possible things that may change later on. Okay? And this is one of the sources of problems in waterfall model. With refactoring, instead, there is less emphasis on upfront design because since you know that you can change later, you start with one reasonable design and you don't try to solve all future problems, but just the one that you foresee now. So you start small. You start with a program, with a library, with a set of classes, with very limited scope. Remember yesterday we talked about the scope as one of the variables sorry. The scope is one of the variables in software development. And scope means how many features you want to implement in your software. And we say that by doing less, you can deliver better quality, develop sooner, and or cheaper, because you don't need to address all the complexity. So again, here I wrote, scope is the only variable that can be controlled easily. Less scope means less time to deliver something meaningful, less cost, more control on timing, opportunity to achieve a higher quality. So what I'm now saying, with refactoring, you can start small. Start with one reasonable design with little scope, one problem at a time. So you don't try to solve all your future problems, but just the ones that you foresee now. Therefore, the design becomes simple, and if an extension is needed, then you first refactor, making your design a little bit more complex or different, and you add your extension later on. Okay? So basically, the idea is that the design becomes more complex only later on in the development and when this is needed. So instead of having one single initial phase in which all the design is made, followed by one single coding phase in which all implementation is done, you are going to split this into small cycles in which you do small design for the features you need now, small coding, then small redesign and refactoring if needed, and coding, and then refactoring and coding, and so on. And so you carry on by small cycle, and you adapt the design as soon as you need it, and only if you need it. Okay, so it looks like a very promising feature. Of course, it's not so easy, as I said, and in particular, when it is not the case that you have to refactor. So this refactor is not the silver bullet, of course. So remember one thing. The code has to work correctly before you can refactor it. So if you have one piece of code which is full of bugs, you first need to debug it and write tests and repeat until you finish debugging. So before refactoring, you need to make sure the code is working. Once you are sure that everything is working, you can start refactoring. Refactoring without tests, it is not refactoring, it's just redesigning from scratch, basically. It's better actually to redesign from scratch if you don't have a good set of tests that you can rely upon. So if you have too many bugs, or you don't have enough tests to run, then refactoring is not the right way to go, and maybe it's much better to rewrite from scratch. Also, if you are very close to a deadline, refactoring is maybe not the case, because refactoring pays off in the long term. It actually pays off after the deadline, for the next deadline. So if you are really in a hurry and you have to deliver your code within a week, then maybe it's better to not spend time in refactoring, but spend time in making sure you are going to meet your deadline. So the first rule is, let's survive. And the second rule is, in order to carry on later, you have to refactor. So, as I said, every time we need to refactor, the first thing to do is to build the tests that check what is going on. Of course, it is much better if the tests are all already there and ready for us. But sometimes you have to write some tests before starting. And this is the only way to understand if the change is correct. I mean, why changing if we don't know what we are doing. We have to be confident that the restructuring is not introducing bugs. And by having a solid set of tests that we can run at any time, builds the confidence into the programmer and makes the fear of change go away. Because you can easily change and maybe revert the changes if you have a set of tests that tells you that you are not doing anything wrong. Okay, so refactoring. What is this refactoring? So if you look at the book, it's actually an old book. And initially, the first version has been written for Java because Martin Fowler is a consultant for Java code. However, most of the things he discusses there are valid for every object-oriented programmer, every object programming language, object-oriented programming language. So basically, it's also nice to read the book, even if you don't program in Java. And today, after so much time, you can find a lot of these refactoring methods and many more on the web. So if you go and look for I don't know, I just okay, so there is refactoring.com, I think is the website part of martinfowler.com, and there is an online catalog of refactoring. This is taken, I think, from the book, and you can see there are many of them. At some point, there was also some research on how to automatize some of these refactoring methods. As a matter of fact, if you download one of the versions of Eclipse, one of the versions of Eclipse for some time maintained 4 or 5 refactoring methods implemented already in the editor. So you could select a piece of code and then, for example, click on extract method, and this refactoring pattern was run for restructuring automatically some part of the code. And this is nice because this refactoring, as I said, it's something that is very small in general. So the idea is that every one of these methods is very small. It's just moving code around your source code. And so it's most of them are so simple they could actually be implemented directly inside the editor. So we are going to see a few of them. We are not, of course, going to see all 72 refactoring methods in the book, but we are going to see a few of them. And in particular, we are going to analyze what they do in general. So methods are organized into groups. We have composing methods, that means how to organize your code into functions, into methods. And every refactoring method has a name. So you have extract method or inline method, or you have replace temp with query, or you have split temporary variable, and so on. Then you have another group which is called move features between objects. And it's related to how to move code across classes and across source files. For example, you have a move method, move field, extract class or inline class, and so on. Then you have organized data, how to organize data into classes. So you have, for example, replace data value with object, or a self-encapsulate field, and so on. Then you have simplify conditional expression, making methods calls simpler, add, remove parameter, rename method, parameter object, and so on. And then finally, dealing with generalization, replacing it with the declaration and vice versa. So when to apply refactoring? So in the book, Martin Fowler says how to understand if I have to refactor or not. Well, the idea is that you have to look for bad code or code that has a bad smell. And in particular, this is a few patterns you should look for to understand if you have to refactor. So first of all, it's duplicated code. If you have duplicated code around your source files, then this is an indication that you should probably do something about it. Another one is long method. You have a long function, you should split it. Then you have switch statement. When you have a switch statement, maybe you should reorganize the code to do something different. Then you have data class, shotgun surgery, long parameter list, and alternative classes with different interface. So let's look a little bit at a few methods that solve the problem of duplicate code, which is probably one of the worst bad-smelling code problems. So duplicate code is, according to Martin Fowler, the #1 in the stink parade. Okay? So when you see the same code structure or exactly the same code in different places in the code, that's a bad idea. It means that somebody did a cut and paste or copy and paste, and this is bad because it's not easy to maintain. The idea is to generalize the code and put it into one single separate function. Okay? If the code that is duplicated is exactly the same, then this is easy. You use what is called the extract method to take the method, the code that is duplicated, and put that into one method. Once you do that, you call that method from all the places where you had the duplicated code. If the code is in two classes derived from the same base class, it means that probably you can put that code in the base class. So what you have to do is to use extract method to build one single function that does that, and then pull up method to implement that method in the base class. Or if you have a similar code in two unrelated classes, you can consider to do extract classes, so to have a 1/3 type of class that implements the method for the two original classes. So let's look at extract method then. So this is contained in Eclipse CTD. Was contained at least. It's a long time I don't use Eclipse, so I don't know. But for some time it was included into Eclipse. It's the simplest refactoring method ever. So the idea is that if you have one print all method that does a print banner and then does this system out print line name plus name and amount, you want to extract the two printing into a different functions, and so you transform the code up into the code down, in which you have two functions, print detail and print all calls print details by passing amount as a parameter, while name is an internal member data of the class. So when to use it? It's very easy. It's in case of duplicated code, or in case you have a method that is too long. So if you have a very, very long function, even if you don't have duplicated code, if you have a very, very long function, it's much better to make it smaller by delegating some of the code into separate functions. And this is because small methods are more readable and easier to debug and understand. And maybe some part of this can also be reused. Okay? So if you have duplicated code or you want to split one long function into 2 or more smaller functions, then you use extract method. You have to pay attention to names. You cannot just put random names. You have to put meaningful names to methods. So you have to pay a little bit of attention. And the reverse of this method instead is called inline method. So if you have a function with just one line, then this is maybe too simple or too silly. Then you may inline the function into the code and remove the function so that your class doesn't have too many functions. So the mechanics, so how does it work? So usually you do like that. So remember, you have some code that is working and you have all the tests. And so let's assume that all the tests run okay. So you have one method that you want to, for example, shorten, and there is some piece of code that you want to extract. So the first thing you have to do is to create a new method and name it. And try to put a decent name to it. Afterward, you copy the code to be extracted into the target method. You copy, okay? At the very beginning, you just copy. Then you look at the extracted code for reference to any variable that is local to the source method. Local temporary variables that are used only in the scope of the extracted code become local variables in the new method. Local variables that are used both in the source method and in the extract code become parameters of the method. And of course, they can be passed by value or by reference, depending on the use and the due methods. Then you try to eliminate or minimize the parameters passed by reference, either by using an appropriate return value or by splitting the code in a different way. So again, you select the code you want to extract. You create a new method, and the parameters of the method will be the parameters you need to pass to the method to make it work. Okay? And in particular, if there is a temporary variable that is used only in the scope of the extracted code, this becomes a local variable in the new method, so it doesn't become a parameter, of course. If you have a local variable that is used both in the source method and into the extracted code, this becomes a parameter. Okay? And of course, if there is something that you need to return to modify, for example, if you are creating something, then you use that as a return of the new method. Once you do that, you compile and you test. Every time you compile, you also test. If everything compiles okay, then you can delete the extracted code from the source method and replace it with a call to the new method you just created. And again, you compile and test. Okay, so it's stupid. In a sense, it's something that everybody understands how to do. But it's also so stupid that it can be automatized. And in fact, this has been automatized in Eclipse. So in Eclipse, you just select the code you want to extract, then you click, and it automatically creates a new method for you with the correct parameters, the correct local variables, and it just cuts and pastes the code in the new method and substitutes it with the function code. So again, an example. Suppose here, and this is a Java example, you have an enumeration E, okay, and which is this enumeration is a sort of iterator in Java, okay, that points to all the elements in orders, and orders is a data member of this class, which, for example, contains all the orders, okay? And then you have a variable outstanding that is equal to 0. Then you print the banner, and then you calculate the outstanding. And so you go across the iteration. So until there is some element in the order, I take the next element and I sum the amount to outstanding. So this just sums into outstanding everything into order. And then you print the details. And how do you transform this? Well, suppose that you want to extract this while cycle here. This while cycle has to be extracted from this print wing because you want it to become a separate function. Well, so you create a new function that is called getOutstanding, okay? And this piece of code uses E, and E is a variable that is used only in this piece of code you want to extract, and nowhere else. So you can actually take enumeration and put that as a local variable in the new method. So getOutstanding also contains enumeration E order elements. And then outstanding is something that you are going to use later on. It's the thing that you are going to calculate. And so this can be a return value of the new function. And in fact, the function will return a double. And this double is calculated in the function. And then you don't use anything else because orders is a data member of the same class, and the new method is in the same class, so you don't need to pass orders to the function. And then nothing else because there is nothing else. So there is E, that is a local, orders, which is a data member, outstanding is something that we need to return. So this is the new function. In the original code, we just substitute the while cycle with calling getOutstanding. Okay, so quite simple. And so what kind of advantage it does? Okay, so these are very simple examples. In this simple example, maybe it's not the case to do this kind of things, but in general, it may be interesting if you have a very, very long function to split the function into smaller ones. Or if you have duplicated the code, so if you have 2 or 3 or 4 functions which go through the same vector and do the same things, then maybe it's better to generalize and to write a function that will go through the vector once and for all. Okay? Another thing we are going to see is this replace a method with an object. And this is useful when you have a very long and complex method that uses a lot of local variables. And the local variables are used in a complex way, so it is difficult or impossible to use extract method. In fact, remember that extract method, all local variables that are used both in the source method and the extract code become parameters. Now, if there are a lot of these local variables, a lot of them, then the new method will have a lot of parameters. And so it's going to be very complicated. In that case, before extract method, we can do this replace method with an object. Let's see how does it work. So you have a class order and you have a method price, which has a lot of these local variables, primary, secondary, numeral elements, blah, 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 blah. And you are going to create a new class that you call price calc, which has these local variables in the method become member variables of this new class. And then it has one method that is called compute, which basically contains all the code into price. Now, in class order, method price now first creates price calc PC this, and then return PC compute. So you moved this price method inside compute. All the local variables became data variables there, and whenever you want to compute this price, you actually delegate the computation to this compute here. Okay? After you do that, this very long compute method can be split more easily inside price calc into separate functions, because these parameters are now member variables, so they don't need to be passed along the different sum functions. Okay, did you get the idea? So the mechanics is you create a new class and you name it after the method. So here you have price, and you call it price calc. You give the new class one field pointing to the original object, so that you can call methods on it. Okay, so this price calc should have a field that points to order. You give the new class one field for every local variable in the source method and for every parameter. So if you have local variables here, they all become data members into price calc. And if you have parameters into price, they all become data members into price calc. Okay? Then you create the constructor that takes all parameters and fill up the fields. So a price calc will have a constructor, which are not shown here. This is called here, which takes as a minimum a pointer to order. And if price has parameter, it will also contain the parameters I need to pass, and it will initialize all these data members. Create a method called compute and copy all the source method into compute. So you take all this code and you copy into compute. And in this copy, of course, you have to adapt. For example, if you were calling some other functions of class order, this has to be transformed here into calling the same method by using the pointer to order. Then you compile, of course. If everything works, it's okay, you're already halfway. You replace the source method code with the creation of the new object and a call to compute. So here, this price is substituted with creating this object, passing the appropriate parameters, and calling compute here. Compile and test it. Now, if compute is long, finally you can refactor as you wish with using extract method, because all local variables are now fields and so are easy to be accessed from the new method. Once you simplified everything and everything continues to work, you may actually discover that the object is no longer necessary, and then you have to eliminate it. But at least you simplify the code by using a very strict sequence of steps every time, making sure that everything works. Okay, so again, these methods are longer to explain, but very easy to apply once you understand how this works. Okay, another one is the pull-up. So pull-up is a little bit more complicated. Let's see how it works. Suppose you have a field that is duplicated in two classes that derive from the same base class. So two sibling classes. It may or may not have the same name. Okay, so you have to understand if it is actually the same field. With pull-up field, you are going to move this method in the base class. If they have different names, you have to rename, compile, test, and then move the field up, compile, and test. So pull-up method, it's the same as field, but you have to be more careful. First of all, you have to actually check if the two methods are doing the same thing. If they are not identical but just similar, you may consider to first do extract method to generalize a common core and later pull up the common core. Now the problem is when the methods refer to other methods, they are in the derived classes. In such a case, maybe you need to define virtual methods in the base class so that you can redirect the calls appropriately. So the idea is that you have two fields of two methods which have the same name or similar names and do similar things in your classes. So you first generalize a common core so they are exactly the same. And once they are the same, you pull it up in the base class. So again, first of all, you inspect the methods to ensure they are identical. If they are not identical, first do some other refactoring to make them absolutely identical. If they have different signature, different name, or different parameters, first you make them uniform, so absolutely equal. So as you can see, the steps are very careful. Every time you do very small amount of changes. And then you continue. And every time you do a change, you compile and test. So to make sure that everything works. So first of all, again, you do make sure that the two pieces that you are going to pull up are absolutely the same. Once you do that, you create a method in the base class, you copy the code, you compile and test. If everything works, you delete one subclass method, compile and test. If everything works, you delete the second, compile and test, and so on. Until you just finish and you have pulled up everything. Okay? Search also where the method is called, and if done via pointer, see if you can change the pointer type to base class so that you can generalize even more. So let's do an example. Suppose you have a customer, which is a class that implements a function addBill, in which you are going to specify the date and the amount of the bill. And then you have two customers, regular customer and preferred customer, and they both have a function createBill, which takes a date, and charge for, which has a start date and an end date. And you want to generalize the two, so you are going to pull up the createBill and generalize the charge for. The createBill you just copy and put into customer. And the charge for, instead, you are going to generalize a common core that you pull up in the base class and a difference which you are going to leave in the derived classes. Okay? So the mechanics is actually quite simple. Okay, let's continue. Extract class. It's when you have one class that does the work that should be done by two. Remember at the beginning of the pattern analysis, we said that you should apply the single responsibility principle for the design of classes. And so one class should do one thing, should be responsible for one thing. And suppose you see that you have one class that is doing too many things. So you should split the class probably into two. For example, you have a class with a lot of methods and a lot of data fields, and it's difficult to understand what the class is supposed to do and what is going on. So you need to split. So again, here I show just a very, very simple example, but you can think of more complicated things, of course. So you have a class person, which contains name, office area code, office number, and as a method, get telephone number. And you want to split and you want to delegate the description of the telephone to a different class, which is called the telephone number. So after the refactoring, you will have two classes, person, which has a name, and as a pointer to a class telephone number, which contains the area code and the number for the office. And as a method, get telephone number, that is just a redirection of get telephone number of person. Okay, and in this way, for example, you can add different kind of telephones for one person, not only office but also home and office cellular number and things like that, which was a little bit more difficult before because the two data members were embedded in the original class. So mechanics of this refactoring method. You have to decide how to split the responsibility of the class into two, of course. Then you create a new class to express the split of responsibilities. If the responsibility of the old class no longer match its name, you may need to rename the old class as well. Then you make a link from the old to the new class. In this case, for example, a pointer office telephone from person to class of telephone number. In certain cases, you may need to have a two-way link. Okay? The telephone has also a pointer to person. But of course, this depends on what you have to do. So don't make the backlink until you find you need it. Then you use move field on each field you wish to move. Move field means you take the field from one class and you move to another class. Okay? So this is a sub-refactoring method. You compile and test after each move. Then you use move method to move methods over from old to new. You start with lower level methods, called rather than calling, and build to the higher level. And after each move, you compile and test. Finally, you review and reduce the interfaces of each class to try to simplify a little bit the interface. If you did have a two-way link, examine to see whether it can be made one way, because it's simpler, of course. And finally, decides whether it is the case to expose the new class to the customer. If you do expose the class, decide whether to expose it as a reference object or as a value object. So in this course. Okay? And now we look at move method that I just mentioned before. Move method is for moving from one class to the other class. Move method is when you have a method in one class and you want to move it to another class. For example, this is when a method uses more features of class 2 with respect to features of class 1. So on the left you have class 1, which has this method, and class 2 that interacts with class 1, and the method in class 1 uses a lot of features in class 2 and almost nothing from class 1. And maybe it is the case to just move the method from class 1 to class 2. In that case, you apply this refactoring. So what you do is you create a new method with a similar body in the class it uses most, and either turn the old method in a simple delegation or remove it altogether. So moving method is actually the bread and butter of refactoring, because we have already seen extract method, we have seen a pull-up method, and move method is the more general one, because you move a function from one class to another one. Okay? And when you need to move methods, when classes have too much behavior, and classes are collaborating too much, and they are too highly coupled. And so you need to remove some of this coupled by moving code from one class to another one. Of course, the idea is that you need to move methods because after the move, the two classes become hopefully simpler, and the implementation is going to be simpler, and the set of responsibilities is going to be simpler. So let's look at the mechanics. This is a little bit more complicated. So you first examine all features that are used by the source method and are defined on the source class, and consider whether you need to move also all of them. If a feature is used only by the method you are about to move, you may as well move it too, of course. If the feature is used by other methods, you may consider move all of them as well. Or sometimes it's easier to move a clutch of methods altogether than to move one method at a time. You have to check the sub and subclasses of the source class for other declaration of the method, because if the method is virtual, it's going to be difficult to move it. Once you have checked that you can actually move the method and the move is going to be convenient, you start by declaring the method in the target class. Remember, in all this refactoring, you start by first adding code, second copying code, and then finally remove the code that you just moved. So at the beginning, you just start by adding and compiling, and only at the very end, when you have copied everything, you just remove the original one. Okay, so you declare the method in the target class, and if you find it appropriate, you may want to choose a different name, so one that makes more sense in the target. Then you copy the code from the source method to the target. You adjust the method to make it work in the new home. So you have to check everything. If the method uses its source, you need to basically have some link back and understand how to go back and take what you need. If there is no mechanism in the target class, you may want to pass directly the source object reference to the new method as a parameter, so you can access the old things. If the method includes exception handlers, decide which class should handle the exception, the original one or the new one. If the source class should be responsible, leave the handlers behind. So basically there is a lot of things to check. You compile the target class because you just moved everything. Then determine how to reference the correct target object from the source, because there are many cases you have to take into consideration, especially when you have virtual methods. So there may be an existing field or method that will give you the target, and if not, see whether you can easily create a method and so on. Finally, you turn the source method into a delegating method. You compile and test, and finally you decide whether it is the case to remove the original source method or retain it as a delegating method. And if you remove the source method, you have to go all across the source code to find the reference to the target method and change it. And finally, compile and test. So it's quite long. So let's look at this example. Suppose you have a class account which has internal object which is called account type. So account has account type. And then, and this is an object which is called type. And then you have another variable that is called days overdrawn. Okay, so let's look at this function now. Overdraft charge. If type is premium, then I have to do something with days overdrawn. Okay, and then finally you have a bank charge result. If days overdrawn 0, result plus equal overdraft charge, which is this function I'm going to move. And finally, I return the result. Now I want to change and move overdraft charge into account type. And the reason is actually very easy to understand, because the idea is that overdraft charge depends very strictly on the type. And so it's better to have this into account type. So I copy the method body over the account type and get it to fit. So first of all, overdraft charge uses type, and that's not a problem because we are going to move this into type. It uses result, which is a local variable, so no problem, this will come with us. It uses days overdrawn, which is a member of account. So days overdrawn needs to become a parameter because the function is going to be moved into account type. And so since it's going to check for days overdrawn, we need to pass this as a parameter. Notice that days overdrawn is just used into read mode. We are not changing this variable. So we can pass it by value. So overdraft charge takes one parameter, which is called days overdrawn, without underscore, because now it's a parameter. If it's premium, we are into account type now, so no problem. Okay, so the code is just the same. And the source method becomes simple delegation. Overdraft charge into account becomes type overdraft charge days overdrawn, and the bank charge now will just call type overdraft charge days overdrawn. Okay, so we just moved the entire method from class account to class account type. Last step, I may need to pass a reference to the original class instead of a single parameter. So if so right now I pass an integer. In some cases, I may need, by moving overdraft charge into account type, I may need to pass a reference to the original object account because I need to do something different. So in this case, what I can do is to pass a reference to account, and instead of passing just the variable days overdrawn, I'm going to implement an access method get days overdrawn, which I can call like that. Okay, in this way, I'm sure I'm not going to modify the variable, and I'm sure I'm not going to do something strange or wrong with that data. Okay. Okay, let's complete with the last part, which is actually very important for being more object-oriented. Replace conditional with polymorphism. So the idea is that you have a long sequence of if-then-else or a switch case, and you are going to substitute the switch case with a polymorphic set of classes. So suppose you have a function getSpeed that computes the speed of a bird. Very stupid example, but that's it. And this function is going to use an internal data member of this class, which is called type. And if the bird type is European, it gets the base speed. If it is African, it gets the base speed minus load factor multiplied by number of coconuts. And if it is Norwegian blue, and it is nailed, it's 0. Otherwise, it gets base speed of something voltage, where voltage is a member of this class. If it is none of these, I throw a runtime exception should be unreachable. Now, this is the typical case in which we want to have a hierarchy, because we have different types of objects, all of them derive from a base object class, and we are switching between different types of it. So hierarchy of objects seems to be the best thing to do. So the first thing we are going to do is to create a class bird, in which you get speed. We already have this, so suppose this is in class bird. And we are going to create derived classes, European, African, Norwegian blue, one for each type of object. Each one has a get speed. It cannot become simpler than that, okay? So now get speed is implemented in different ways in the different classes. So before you can begin with this refactoring method, you need to have the necessary inheritance structure. So you may already have this from previous refactorings, otherwise you need to create it. Okay? So first step, if the conditional statement is one part of a very, very large method, the first thing you need to do is to isolate this conditional statement into a different function. And you can do that by using extract method. So if this switch case, instead of it being a separate function, is part of a long function, you extract it and you put it into a separate function. The function should only contain the if-then-else statement. Okay? If it is necessary, use move method to place the conditional at the top of the inheritance structure. Okay? So in this case, we put that into the bird class. Then you pick one of the subclasses. You create a subclass method that overrides the conditional statement method. You copy the body of that leg of the conditional statement into the subclass method and adjust it to fit. You may need to make some private members of the subclass protected in order to do that, so that the derived class can access it. Okay, so you start with this, and you start by moving the first leg, get by speed, into European. Okay? You compile and test. Then you remove the copied leg of the conditional statement. Compile and test. So you take this European, you move this part into class European, compile and test. Then you remove this part, compile and test. Repeat with each leg of the conditional statement until all legs are turned into subclass methods. Okay? So you continue with African, do the same, you move the code of that specific leg, compile and test, remove the leg, compile and test. And you do the same with Norwegian group. At the end, this should be completely empty. So now you can make this abstract, so virtual, and everything should work. So the inheritance structure is that you have one class here, which points with a type to employee type, and then you have different. So switch code, another switch code we want to transfer. Suppose you have the employee, which has a type, employee type, and you have engineer, salesman, and manager. And you want to pay differently for every kind of employee. So engineer, it's paid less than salesman. I'm sorry, guys. And salesman is paid less than a manager. So depending on the type code, you pay get monthly salary, or get monthly salary plus get commission, or get monthly salary plus get bonus. Okay, so how to split this is quite simple. You are going to create a function pay amount on each class. So I change the pay amount method in employee to delegate to the new class. So pay amount into type pay amount. You copy the engineer leg of the case statement onto the engineer class. Carry on until all methods are implemented, and then declare the superclass method. Abstract is in Java, virtual is in C++. Okay, and so basically you have done everything. So refactoring means, as I said, you do step by step very small modification to the code, trying to improve the structure of the code. If you have time in your future as you go to work into software industry, I highly recommend you to read the original book by Martin Fowler. I think it can be found for not so much money around, or you can find on the university libraries. Because in addition to the description of the methods, there is a very nice introduction to the entire methodology, which is quite nice. Okay, so this is the book. Refactoring, improving the design of existing code. Okay, so now I start very quickly in the next 10 minutes to describe you this entire agile methodology, which has been implemented in many different methodology of software development. And the most popular today is called Scrum. So Scrum is one of the many agile methods you can find around. So this is a presentation by Claudio Scordino. Claudio Scordino is an engineer at Evidence who was certified in one of the courses, official courses of Scrum methodology some time ago. So this is a very long set of slides by Claudio that you may want to have a look at, and that describes in very deep detail the Scrum methodology. So we are not going too much into the details, also because I'm not an expert of Scrum methodology. So I will just give you an idea of what is it by going very quickly through his slides. So here again, historically, we have the waterfall methods, or the V method, and this is the historically how many software industries were developing software until some time ago. And the problem is that this doesn't work for software. So it may work very nicely in other engineering domains, but doesn't work very nicely in software. Because software is quite different from products of manufacturing. And the most important feature of software development is complexity. And the complexity increases much more than linearly with respect to the size of the things you have to do. And also software can be changed easily and with a low cost, and so it's easy to change it very easily. And there is also a large variability, and finally software is not tangible, is invisible. So waterfall is very old, introduced around the 70s, and it's very rigid. And actually, this fact that waterfall is not good is not just something that comes from academics. It's something that comes from reality, because at some point in the 80s, people started to realize that the percentage of software products, software projects that were not completed in time or were not even completed was astonishingly high. So something like in the US, in the 80s, about 50% of the software projects were not completed at all. And more than 80% were completed later and with a larger amount of money with respect to initial estimates. So developing software was a sort of nightmare in the 80s, simply because they were not using the right and the correct approach. And for example, there are something very famous I'm going to tell you, is one big failure of developing a system for FBI, and this is called the virtual case file. Virtual case file, or VCF, is a software application developed in the United States Federal Bureau of Investigation between 2000 and 2005. And the project was officially abandoned in April 2005, while still in development stage and cost by the federal government, after spending $170 million. So $170 million completely wasted because the software project was completely cancelled. In 2006, the Washington Post wrote in a 380-page report completed in January 2005 and obtained by the Post under the Freedom of Information Act, the Aerospace Corporation said that the psych software was incomplete, inadequate, and so poorly designed that it would be essentially non-usable under real-world conditions. Even in rudimentary tests, the system did not comply with basic requirements, the report said. It did not include network management or archiving system, a filing that would put crucial law enforcement and national security data at risk. So basically, the idea of this software was to informatize FBI, because the problem with FBI was that it's Federal Bureau of Investigation, but the number of software systems used by the different offices in the United States was very large, something like 50 or 100 different kinds of systems. And many of them were half computerized, half paper, and different databases. They were not speaking with each other. And for a Federal Bureau of Investigation was not very nice, right? So they say, okay, let's do a very, very good system that integrates all this data at the national level so that we can quickly and easily find all the information we need with just a few clicks of a mouse, okay? And after 5 years and 170 millions of dollars, they canceled everything because it was not working. And there are many reasons for failure, and look at this. The project demonstrated a systematic failure of software engineering practice. Lack of a strong blueprint from the outset led to poor architectural decisions. And basically this means that the specification was incomplete. Repeated changes in the specification. Repeated turnover of management, which contributed to the specification problem. So people were changing very often at the head of the management of the companies that were developing this. Micromanagement of software developers, trying to control every single aspect. The inclusion of many FBI personnel who had little or no formal training in computer science as managers and even engineers on the projects. Scope creep, as requirements were continuously added to the system even as it was falling behind schedule. So basically they started small, but the number of requirements were continuously increased. Code bloat, due to the changing specification and score creep. At one point it was estimated the software had over 700,000 lines of code. 700,000 lines of code. Okay, so the Bureau faced a great deal of criticism following the failure of the VCS program. The program lost 104 million in taxpayer money. In addition, the Bureau continues to use the antiquated ACS system, which many analysts feel it's hampering the Bureau new counter-terrorism mission. In March 2005, the Bureau announced it is beginning a new, more ambitious software project called named Sentinel to replace ACS. There is also a very interesting article about this in IEEE Spectrum, which describes in a lot of more details the case. But this is only one of the many cases of software failure in the United States. And this is why there is so much research and so on alternative methodology for developing software. Okay? The software has the power to become a monster capable of missed schedules, blown budget, and flawed components. This is another example. You can click and see where it goes. And it was another huge amount of wasted money into a project that was cancelled before the end. So, what are the issues? We already discussed this yesterday, but let's have a look again. So, requirement issues. Requirement changing or not available. Customers don't have any idea of what they want. Often, customers are not computer scientists, so they have no idea of what to expect from a software. Okay? And customers change requirements after design very often. Very often the customer wants to see something before deciding what he needs. So the requirements is available only when the customer finally sees something. And it is difficult to specify some kind of requirements, for example, look and feel of a GUI. So the customer will never be able to specify in very detail how the window with the commands should look with, unless he can play with it. So the requirements will arrive after he has something to play with. And this is true in almost all software. Of course, there is critical software is a little bit different. For example, the control system of a car, well, you don't have the customer so strictly in the loop, right? There, the customer is probably the software engineer, the control engineer that has to control the engine. So there is a little bit different. But otherwise, the final customer needs to have the product before he can decide what to do with the product. Technology unknown, partial ignorance of the technology that is going to be used. Only during implementation the developers discover what they can do and what they cannot do with that technology. For example, in a embedded system, unless you have your board, you don't know if it is powerful enough for what you have to do. Or unless you have your library and you can play with that, it's not easy to understand if that's the library you need for implementing your own thing. So unanticipated technical problems, and this affects requirements and may impose a change of technology. So only at implementation, developers discover the actual time needed for development. So at the very beginning, how much does it take to develop a piece of software? Nobody knows. We just invent numbers. So in real software practice, it's very difficult to forecast how long it's going to take to implement something. So it's experience, but it is also trying to make up numbers. Release issues. Market technology has changed. Market changes continuously, even during our development. And so if a competitor releases a better product before us, we need to change direction and differentiate. New technology evolves or becomes available during development, so we have to change and use the new technology, or the company changes direction. So the big problem with the waterfall model is that it assumes that after the phase of requirements, nothing changes anymore and everything has been understood. But this is not true. None of this is true. So therefore, our model must assume that change will not be small and manageable, and suppliers or customers cannot fully understand all the requirements upfront. So with waterfall, you only have the illusion that the development process is under control, because the supplier gives this illusion to the customer and uses Gantt charts to prove that everything is under control. But actually this is not, because it's very difficult to estimate effort, it's very difficult to forecast changes and things like that. So when change happens, the supplier usually hides the problem with wishful thinking that everything will be fixed by increased overtime, dirty fixes, more working people. But of course this doesn't work. Okay, so waterfall doesn't work with software, and you can have here there are many references of books that show that the waterfall model doesn't work. And okay, more and more books. So the Agile Manifesto is these people proposing a complete change, and the complete change is actually can be summarized in a small iteration with customers in the loop. Okay, so the essence of agile software development is small iteration and customer in the loop. So we are uncovering better ways of developing software by doing it and helping others to do it. Through this work, we have come to value individuals and interaction over process and tools. So rather than a fixed process that has to be followed strictly, focus on people and the interaction between people. Second, less documentation, more working software. The idea is, instead of spending months and months writing Word documents listing how to use the software, it's much better to spend time producing simpler working software that the customer can immediately use. Customer collaboration over contract negotiation. That means customer in the loop And rather than the customer there and we are here and the contract in the middle that separates us, collaboration with the customer to achieve the goal of producing better software. And finally, rather than following the plan, responding to change. So be flexible. So responding to change over following a plan. Okay, now there are 12 principles. So satisfy the customer, changing requirements are okay, even they late in development. Deliver working software frequently. So you immediately show that something is working in the to the customer. So early mock-up that customer can play with. Even if it is not doing almost anything, it doesn't matter. You show the customer something. Business people and developers must work together daily throughout the project. Build projects around motivated individuals. The most efficient and effective methods of conveying information to and within a development team is face-to-face conversation rather than memorandum, emails, the official documentation. Working software is the primary measure of progress. Sustainable development, that means people should not work 80 hours a week, but a constant pace all over the project. Continuous attention to technical excellence and good design enhances agility. Simplicity, the art of maximize the amount of work not done, is essential. So you have to maximize the amount of work not done. The best architectures, requirements, design emerge from self-organizing teams. So people organize themselves individually and between each other in small groups. And at regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. So as you can see, all these 12 points are very flexible and very agile in the sense that people should adapt to the process with the goal of achieving a working software. Okay, so for today I stop here, and we will complete this tomorrow. So tomorrow it will be last lecture of this course at 11 tomorrow morning. Okay? You have questions? Okay. See you tomorrow then.
Okay. Bye-bye.
Bye-bye.